Today we're going to talk about all the planets. The first four planets are rocky planets, or terrestrial planets: Mercury, Venus, Earth, and Mars. And these are the first four that are closest to the Sun. They all have rocky crust, dense mantles, and they all have cores, just like Earth does. Now, all terrestrial planets have layers. The metal is in the center, like iron is in the center of the Earth, and all the lighter rock forms a mantle and a crust. Now, one characteristic of all four of these planets here is that they all get craters. Meteors hit every one of these four planets. Oh, what a bad line. I'll try to circle around. Anyway, I should have just not underlined. Well, anyway, meteors hit these planets occasionally, leaving craters. And the craters are actually up to 10 times the size of the meteor in the first place. Most craters on Earth have been erased by erosion. You know, we have water erosion, we have wind erosion. Other planets don't have the water erosion. So since other terrestrial planets don't have the water, the craters are going to be more obvious on them. And as you look at this picture here of Mercury, you can see lots of craters here. You can see lots of craters. This is Mercury. Now you see some facts about Mercury here. Mercury is the smallest planet. It's only about 6% of the size of Earth. And as you see, it has many, many craters. You know, if you look at Mercury, it looks very much like our moon. Now, there are some smooth parts. You can see a little smooth part right out in here. These smooth parts, scientists think, are where lava covers the surface. So they do think there is volcanic activity on Mercury. It rotates very slowly. Their day is 59 of our days. Shoot, it only takes 88 days for it to go all the way around the sun. So in 2 days, you have over a year. Now, Mercury gets incredibly hot during the day since it's near the sun, about 800 degrees Fahrenheit. But since the nights are so long, the night temperature can actually dip to well below freezing, 280 degrees below freezing. Let's talk now about the next planet, which hopefully you know is Venus. Venus is the second planet from the Sun. It is a little bit smaller than the Earth. It's often called the sister planet of the Earth. Now, it even rotates slower than Mercury does. It takes 243 days for it to rotate one time. And since it takes 225 days to revolve around the sun, its year is actually shorter than its day. Anyway, Venus's atmosphere is very, very dense. The air pressure is 90 times the air pressure here on Earth. Now, the temperatures of Venus actually even get hotter than Mercury, because the atmosphere is made of carbon dioxide and it has these thick clouds that cover it. Now notice you can't see craters like you can on Mercury because all these are thick clouds, and the reason it has the clouds are because there are droplets of sulfuric acid that are in the atmosphere which form these clouds. We're not going to talk anything about Earth because, well, you grew up there and you know all about it. So we'll skip on to the fourth planet and the fourth terrestrial planet, and that is Mars. Mars is about half the size of the Earth, but much, much lighter. Molecules of iron and oxygen on Mars produce rust, which makes the planet look, well, reddish orange. And you can see even from this photograph here that it kind of has that reddish tint to it. Now, Mars is a little bit like Earth in that it rotates every 25 hours, and we'd have every 24 hours. So their day is similar to ours. It revolves around the sun a little bit longer than our year, in fact, closer to 2 years. But unlike Venus, the air pressure on Mars is complete opposite of the Earth. It is only 1% of that of the Earth. So you have a lot of low pressure, and you probably can guess what comes with low pressure. You also have extreme temperatures. You can even have up to 60 degrees during the day. Hey, that is something we could be comfortable with, 60 degrees. But at night it can get down to negative 130. This huge temperature difference makes for incredibly fast winds because you have high pressure and low pressure. The heat's going to produce a little bit more high pressure, and you have high going to low, and you'll have very fast winds here on Mars. And one thing you can notice, we have pictures of the surface of Mars, and by the way, this was a picture of the surface of Venus. But one thing you notice on the surface of Mars is all these rocks. These rocks are there because the wind has been so high, it pretty much just blows all the debris away around from it. And you notice here on Venus, that's not the case. You have things that look kind of even soil-like there that wind has not done anything with, because all the wind is there on Mars. And you can see that there are mountains in the background, so it does appear that there has been some tectonic plate activity there. We'll continue. Like Earth, Mars has polar ice caps. Their North Pole and their South Pole have ice on it, but it's not the ice like we have here. The ice we have here is frozen water, but this on Mars is frozen carbon dioxide. In other words, it's dry ice. There is no water on Mars' surface today, but there appears to have been water erosion at some point in the past. And frozen water has been found in the ground and in one polar ice cap. Now let's go to the other planets. Now the other planets are categorized a little bit differently. They're not made of rock. They're not terrestrial planets. They are gas giants. Jupiter, Saturn, Uranus, and Neptune are the gas giants of our solar system. They're not rocky at all. They're made of gases like hydrogen and helium and some other gases. These gases actually are in such high quantity that these planets are very dense. And at some point inside the planet here, the gas is so dense that you could categorize it as liquid. This area here, even though it is gas, it is so dense that you could categorize it as liquid. And at some point it gets so dense that you can even categorize it as a solid. And this little core area right here, scientists can practically call a solid, even though the entire thing is made of gases. It's just gases so dense that it's solid. And each one of these four gas giants has a core larger than the Earth, or at least that's what scientists think. Let's talk about Jupiter. Jupiter here is the largest planet, and it is by far the heaviest planet. It is over 1,000 times heavier than the Earth, even though it's only 10 times larger than the Earth. If you were to take all other planets and put them together in our solar system, they would still weigh less than half of what Jupiter weighs. It takes Jupiter 12 years to revolve around the Sun, but what's unique about Jupiter is its rotation. Its rotation is very fast. Its day is 10 hours, which makes for incredibly windy and stormy conditions. Now, Jupiter has what looks like these stripes on it. Now, what these are wind belts. Since it is spinning so fast, it has these belts, kind of like our global winds, like trade winds, except to a huge degree. And you can actually see them from space. And they have storms. And what stops a big storm like a hurricane? It's land. But there is no land on Jupiter. So you can have these big storms that can last for a long, long time. The largest of these storms is the Great Red Spot. That's what scientists call this. They think this is actually a storm that just doesn't have any land in which to stop it. And it's twice as wide as the Earth, and it's been there as long as we've known Jupiter has been there. So that's at least 100 years old. Let's talk now about Saturn. Saturn is only a little bit smaller than Jupiter, not near as heavy. It still rotates very fast. Its one day is in 11 hours, but the storms and wind are not as visible as they are on Jupiter. You don't see as very visible belts of waves of wind there, I should say. And it takes about 29 years for it to go around to the sun. Now, the big thing about Saturn is the rings. Now, all gas giants are going to have rings. It's just that these rings are more obvious on Saturn. Even Jupiter has them. You just can't see them there. What these rings are is ice. It is ice. They're icy rings. They're chunks of ice that are in rotation around. They're kind of in orbit around Saturn. Now, one thing about Saturn also, it does have a tilt, and the tilt is even bigger than our tilt. It's about 27 degrees. Which brings us to the final two planets in the solar system. They are also gas giants, Uranus and Neptune. Uranus is made of heavier gases than Jupiter and Saturn are. And as you can see, it appears blue-green. It's kind of like a robin's egg, you might say. The color actually comes from methane gas. Who would have thought that that would have had such a color? Well, anyway, it's way in the outer reaches of the solar system. It's twice as far away from the sun as Saturn is. It's closest planet to the sun. And it takes 84 years for it to get around the sun one time. Now, it has such a huge tilt, it actually spins on its side. Whenever it rotates, it spins on its side, and that's something very unique to all the planets. Finally, we're going to talk about Neptune. Neptune is the farthest out of all the planets and the last gas giant. It's also made of these heavier gases, and as you can see, it appears a deep blue, kind of like our ocean. Even further in the outer reaches of the solar system, it takes 164 years for Neptune to revolve around the sun. Now, Neptune will occasionally end up having these white spots. These white spots, scientists think, are clouds. They're clouds of methane ice crystals. And it will have darker areas too. You can see a darker area right here. This was a spot that was spotted on Neptune several years ago. The darker areas show up, and there was a flyby that saw that particular spot in 1989, and it was nicknamed the Great Dark Spot, and scientists thought it might last just like the red spot in Jupiter does, but it was gone a few years later when the Hubble telescope photographed it.